Thank you. So as you heard, my name is Mark Dalgleish, and I'm here all the way from Melbourne, Australia. And believe it or not, my clicker isn't working. Yes, it is. I've been working in the web since 1999, where I first got my start with HTML, and of course, very soon after CSS. And it probably goes without saying, given that I'm here, that I really love CSS. But I've also been a big part of the React community the last few years. I'm a huge fan of the React model and what it allows us to do with our products. And out of the React community came my work with CSS Modules, something many of you are probably familiar with. And it's a very popular alternative to CSS-in-JS. It brings the component scoping model to CSS. And given that, you might be surprised that I'm not actually here today to talk to you about CSS Modules. I am here today to talk to you about CSS-in-JS. Please don't all leave immediately. I think CSS-in-JS, even though I don't use it in my own work, is a really interesting thing to look at. What I find frustrating, though, is that being part of the React community and seeing all this work, often what's said to these people is that they should just learn CSS, that they're just avoiding it, that they're trying to do everything in JavaScript. And what I think is at the core of this is, there's this separation here going on, I think, that people think is there. But for me, it's not there. I'm a big part of the React community, as I said, and I love component systems. But I've been around the web for a long time, and I'm a big fan of progressive enhancement. That's actually what brought me to React in the first place. And I bring this to my own work. So this right here is a video of what I've been working on the past few years in Melbourne at Seek, which is the leading job site. Now, what you're looking at is a single-page app built in React. It's responsive, it's fast. It's a single-page app, so it's all rendered in the client, hitting APIs and rendering in your browser. But the catch is that everything you're seeing here, I actually disabled JavaScript in my browser. So despite being a single-page app written in JavaScript, you can run it without JavaScript. And that's what React allows us to do. So I'm very interested in CSS and JS. Again, even though I'm not using it in my own work, I'm keeping a close eye on it. And I think you should be too. That's the important point. And I think that's why I'm here today. But why? Why are people doing this, and why should you be interested as well? There's 5 key reasons I want to cover today. There's more to it than this, but I think these are the practical benefits you get from taking on this approach. And even if you're not going to bring this into your own work, I think it'll help you get a sense of why people are doing something that seems maybe ridiculous from the outside. So we're going to look at scope styles, we're going to look at critical CSS, smarter optimizations, package management, and finally non-browser styling. So the first one is scope styles. Now, I guess I don't have to convince you of the fact that managing CSS at scale is really hard. So much so that I'd say that it's the hardest problem in front end. Because if you think about working with multiple people on a large project over a long period of time, if you don't have much structure, what's the technology that goes downhill the fastest and becomes unmaintainable? It's CSS. And that's something that the CSS community has known for a long time, and we've been working hard to solve it. The big entries in this is OOCSS from Nicole Sullivan. We've got Smacks from Jonathan Snook. And we've also got BEM from Yandex, which, from my experience, seems to be the one most popular in the wild. Now, BEM is a naming convention for your classes that I'm sure you're all familiar with. But at the end of the day, BEM is just a convention. There's nothing stopping you from not writing your classes in a BEM style at any given moment. But even so, it's a fantastic way to manage complexity at scale in our code bases. In fact, I'd say that if you're working in CSS at scale, an approach like this is invaluable. But if it's so central to managing CSS at scale well, why is it just a convention? This is something that I wrestled with quite heavily. But when you look at it closely, particularly in a component system, BEM blocks are essentially components. It's the same abstraction. And when you're working with a single-page app framework or library like React, your components are defined in JavaScript. So having your CSS follow the same scoping rules as your components is really valuable. What we're going to do now is we're going to take a quick look at a library that does this. This is Glamour from Sunil Pai. And basically what it does is it allows you to define your CSS in JavaScript. But the key thing is that whenever you define a set of rules like this, it generates a class for you automatically. So that means that you don't have to worry about scoping it in the global namespace. That's handled for you. And so the hashing classes is done for you rather than by name, by hand. And so we're enforcing that scoping at development time. One thing I really have to address early on, it's kind of the elephant in the room. These libraries, or at least the most recent ones, they don't do inline styles. They are all about generating real CSS and inserting it into the document, exactly what you would have written by hand. Another entry in the CSS-in-JS space is JSS by Oleg Solobodsky, and he's actually from here in Berlin. But like I said, because it's not inline styles, it's real CSS, we can do things like add hover stylings, we can add media queries, and these will all work the way you would expect. When you attach these styles to the document, that's the moment at which it hands the classes to you. So now you have a reference to those classes. And when you insert some markup into the document, whether it's by some fancy framework or even just inner HTML, you can now interpolate those classes into the HTML like so. So here our class is classes.heading, and that evaluates to a string that was generated by the library, not by us. So scope CSS is all about scoping to components. That's what this is all about, and that's why you see this work coming out of the React community and similar libraries. So much so that there's often bindings for the libraries, like React JSS. So here, what you're seeing is that we're injecting the styles at the bottom there, we're injecting them into the component, and then within the component we have access to those classes. So in a sense what we're doing is we're generating a little style sheet for every single component. And if you're looking at this and wondering, what about separating concerns? Do I have to put my styles in the same file as my JavaScript, as my components? And even though a lot of people do, there's nothing stopping you from architecting your app differently. You could extract your styles into a separate file and export them, and then where you want to use it, you can just import them at the top of that file. But what you're doing is you're making an explicit reference from where you define the styles to where you use them. The maintainability of your styles is greatly increased at this point. But what's important here is your styles are now passed around like regular code. It's not something that sits in the global scope implicitly. It's something that you have to hand around your application to the components that need it. And component scoping is now automated for us. This is the basis of working in an environment like Atomic Design, where it's all about components all the way down. And to do this at scale effectively with multiple people, we need to scope our CSS. The key thing here is that BEM, a best practice in the CSS community, is now baked in. It's not opt-in. It's not something you have to remember to do. It's done for you. Now, at this point, you might be looking at it and thinking, if you're familiar with CSS modules, that's exactly what CSS modules does for you. And that's right. So if that's all you want, CSS modules will do that for you, and it's really great. But another feature came along that people were experimenting with that really opened my eyes to the possibility of doing styles in JavaScript, and that's critical CSS. Now, Patrick's already covered a little bit of this earlier today, but just for a quick recap, this is something that Google PageSpeed have been talking about for a while now, and recommending that you do in your applications. And that's inlining styles for the current page in the head of the document to improve that initial rendering speed. So it looks something like this, as we've seen before. You're inlining the styles that are relevant to this page in the head, and then the rest of your style sheet can safely sit at the bottom of the page, delaying the full style sheet until later when it's needed. There's some really great tooling out there for automating this. There's a project called Critical from Adi Osmani that does this for us. And it's really great to do this, of course, for obvious reasons, speeding up that initial render. But the problem is that, well, first of all, it's an optional optimization. It's something you have to add in later. But as Patrick said as well, my click is playing up. It's hard to maintain and it's hard to automate. And I completely agree with this. It's quite a heavyweight system. It's powered by Phantom.js. It's not something you'd want to do on every request on a server, for example. If you look at CSS-in-JS, though, in a server-rendered environment, it's the complete opposite. Because with CSS-in-JS, critical CSS is not just an optimization. Server-side CSS-in-JS actually depends on critical CSS to work. A good example of this is the library Aphrodite from Khan Academy. And it looks something like this. So at the top there, you can see we're defining our styles next to our component, as we've already seen. But what I want you to pay attention to is inside the render function for that heading component, every time we reference our styles, we're wrapping them in a call to the CSS function. And what this function is doing is it's allowing Aphrodite to keep track of every style that's being used at any moment in time. So if you do a full render of the application, Aphrodite knows exactly which styles you need, exactly which styles you don't need. So that means that on a server, when you're rendering server-side for every request, you can hook into Aphrodite and render your application to a string, and part of that is getting both the HTML and the CSS for that render. So now getting the critical CSS is something that's automated for us on every render. Here we're generating a string of a style tag, and inside of it we're inserting the CSS content that was generated for us by Aphrodite. And if you've worked with React on the server or seen how it works before, you'll see that this is very familiar because this is exactly what you do with React as well. So even though React can run in the browser, we can also render it on the server, and all the HTML that React generates for us, we can insert into this string. So now we have static HTML and static CSS. So the key thing here is that even though we're defining everything in JavaScript, you might think that JavaScript is required, but this is built for progressive enhancement. The browser can completely shut off JavaScript and things will still work as expected. So even if your server rendered, or if like what we do at Seek sometimes, is statically pre-rendered to HTML. So even for simpler static sites, we can leverage the same components and we can render to static HTML and CSS. And again, there's a bit of a theme here, which is that the best practice of critical CSS is built in. It's not opt-in when you work in this environment. The third point I want to cover is smarter optimizations. And this is all based on the fact that CSS-in-JS has better integration with your markup, as we'll see. Now, in the CSS community, there's been a big focus on how we can reduce our CSS bundle to the absolute minimum. As we add more and more styles to our application, our style sheets grow larger and larger over time. And how do we deal with that? There's been some really interesting work from Yahoo in Atomic CSS. They use a really interesting, somewhat controversial function call style syntax in their classes. And from this, they can use some tooling to generate a style sheet for you. There's also Tachyons from Adam Morse that does something similar. It's a slightly more opinionated framework style, and it gives you a suite of classes to choose from and apply. The idea is that once you get familiar with the library, you'd be able to read these, of course. And the key idea that they're pushing here is that they're treating classes like inline styles to try and reduce the CSS in that final bundle. Now, to me, this one is a little bit of a mixed bag in the sense that I value the output. I think it's worth trying to cut down the CSS bundle, but it comes at quite a cost at development time. You have to buy into a framework or you use an obscure syntax. And these sorts of things are hard to use in a team environment where maybe not everyone's familiar, not everyone's bought in. So I'm not so sure on this one. But if you look at the way CSS-in-JS works and CSS modules as well, you never hard code a string to a class. It's always a reference to a string that's provided to you either from the library or from the tooling. So here we're saying that this aside uses the styles.sidebar class. But because that's a reference to a string, it might resolve to a simple string like sidebar. Or for all we know, it could be made up of several classes, dozens of classes. It's actually not out of our control. It's the tooling that takes care of this for us. So that opens up some really interesting possibilities. The perfect example of this is a really great library called Styletron by Ryan Sau. And this one really, to me, shows where we can start to do radically new things once we blur the lines between CSS and JavaScript. Because what it brings to the table is dynamic zero-config atomic CSS. All the benefits of reducing that final payload without the development time costs, without having to buy into a framework in the same way. So what I want to show you here is what it kind of looks like in practice. So on the left there, what you've got is 3 different sets of rules being defined. And on the right there, you've got the final generated CSS. The first thing you'll notice is that the generated CSS is half the size. And why is that? It's because there's a lot of repetition going on. So font size of 1.6 M is in the first and the last one. A height of 32 pixels is in the top and middle set of rules. And display inline block is in the last 2. So that means, in effect, we've really only got 3 unique combinations, so we only need 3 classes. And this is something that Styletron can take care of for us automatically by generating these virtual class strings in the middle. So you notice we've got classes of AB, AC, BC. That's encapsulating what's in common between these different styles for us. So that atomic CSS style string can actually be generated for us. So in code, what that looks like at its lowest level is Styletron gives us an API to inject a single declaration of a property, value, and media query combination. Again, this is not inline styles, this is generating real CSS. And for this, what we get is the class A. This is the first class we've generated. So once we start to generate classes for multiple rules, what you'll start to see is what we saw before. So here the color red is used in both the first and second sets. So we get the class A. But display inline block and font size 1.6 ems, they're different, so we get different classes. So all the common styles are factored out for us, but it's hidden away behind this abstraction of generating the class names for us. So what that means when we generate our final bundle is that when you compare Styletron to other CSS and JS approaches, you get half the size of the bundle basically, because it's able to aggressively optimize down to the minimum set of combinations of property, value, and media query. And just to be clear as well, this is real-world CSS. This is actually from Airbnb, this set of CSS. And again, the trend continues that the best practice in terms of generating the smallest output of atomic CSS, it's now baked in, it's not opt-in. And we can only do this because now we have closer integration between our markup and our styles. The fourth point, I think, is where I really start to be sold on this idea, and that's around package management. I want you to think about how we share CSS. We've been doing it for a long time. How do we do it? You might think that we've had package managers that are friendly to the front end like Bower, and that's true. But even when you're using package managers like npm, when you're including CSS into your application from a third-party package, the inclusion step is generally a manual step. It's something that you have to go out of your way to wire into your application, which is completely different from the code that you're installing. And I think the key reason why this is happening is because our CSS and the package managers that provide it are not coupled to a module system in the way that we've seen with npm and CommonJS modules. Because when you think about what happens on npm, for example, and how it deals with packages that have dependencies of dependencies of dependencies, they're easily able to manage that fact. But with CSS, it's something that we can't really do very well. We can't build CSS built up of other CSS. And I think you see this trend play out in terms of the different styles of package managers. So Bower, as a package manager, had this problem as well. It was very much about flat dependencies, whereas npm is more about a web of dependencies, small libraries that many, many people provide. And it plays out, I think, in the exponential growth of the number of packages being created. When you have a flat set of dependencies, like we've seen with Bower or like we see in the CSS community, what you end up having is monolithic dependencies, big libraries. This is what leads to things like in the older world of front-end single-page applications, you might install jQuery, you might install underscore, you might install backbone, and then you were done. Because you didn't really have a good way to manage much more code than that. And in the CSS world, we've seen the same things where you would pick a framework like tachyons, for example, and then that was it. So where's our package manager for CSS, for Sass, for less? We don't really have one that's catered to that specific need, that really tackles it in the same way that we've seen elsewhere. But what I want you to do is think a little bit differently about the web platform for a second, and you think about where's our package manager for HTML? We're putting all this focus on CSS. Well, if you think about it, we already share HTML a lot, but we share it via JavaScript. So you install jQuery components, you install Backbone components, Angular directives, React components. These are all encapsulating HTML in JavaScript, and that's what enables us to share and build on top of each other in a way that wouldn't be possible if we were just using static HTML. So the question is, what if we started sharing CSS via JavaScript and npm in the same way? Packaging up our CSS behind JavaScript in the way our HTML templates are as well. Instead of mix-ins, we have functions that operate on plain data, strings and objects. Instead of extending rules, we just use built-in syntax like the new object spread syntax for spreading objects of rules together. Now this means that we can compose and share our styles like any other code in our application, and we can leverage package managers to do this. A good example of how this plays out is a really great library called Polished by Max Stoiber, who couldn't be here today, and Nick Graff. And Polished is really the Lodash of CSS and JS. It's a whole suite of utility functions for operating on CSS in a JavaScript environment. But more importantly, it's not relegated to the style part of your application. You can use this anywhere. And this is particularly useful if you're doing things like building style guides and you want to programmatically have access to the logic behind your CSS. This is a problem we face all the time where I work. And having the logic in JavaScript neatly solves this problem. So the hope is that once you move towards expressing CSS in JavaScript, we can start to see open source CSS look more like the NPM chart there, where more and more styles are built upon, shared, low-level functions are written and built upon and shared in a way that we haven't done before. And ironically enough, we can do this by embracing JavaScript modules, a module format that's widely supported today. The final point I want to cover is much more future-facing. This is not necessarily something that the CSS-in-JS community is particularly big on, but I think it's something that really is not possible today in the CSS community, and it's really interesting, and that's non-browser styling. Now again, like I said, I've been a big part of the React community, and React's really interesting for a number of reasons. But one of the big reasons is the fact that you don't deal with DOM manipulation directly. You deal with virtual DOM. You deal with a representation of what the final DOM will be rather than touching it directly. And what that means is that when it comes time to render, you actually use a renderer for that environment that you're dealing with. So here, when you render your React app on a server or on a client, you're pulling in from React DOM, something that's built for dealing with the DOM. But the fact is that React core can actually have different renderers. You don't just have to target the DOM. It's not just virtual DOM, it's virtual whatever it is, whatever the primitives are of the environment that you're working in. So you would have seen that play out with React Native, something that I'm sure you've all seen before. And React Native is about bringing this idea of working with virtual representations of the final components. In this case, you're dealing with native components. But what's interesting about React Native is they wanted to make it friendly to people like us, web developers who know CSS in and out. And it comes with its own style sheet abstraction. So even though you're working in a native app, you style your apps with what appears to be CSS. Here we're creating a style sheet with very familiar properties, border radius and width, color, font size, and font weight. But what's really interesting about it is the fact that you can use Flexbox. This is an environment that's completely outside of a browser, doesn't natively have Flexbox, and yet here we are using Flexbox in an iOS or Android application. The way they achieved this was actually by re-implementing Flexbox in JavaScript in a project called CSS Layout. And there was a massive test suite making sure that it followed the spec correctly. And this allowed them to bring the world of Flexbox into their native apps. It's now been formalized in a project called Yoga that's targeting a lot more environments. So now it's actually no longer written in JavaScript, it's written in C. It targets Java, C#, Objective-C, and C as well. But what's really interesting about Yoga is they've said that their focus is on creating an expressive layout library, not implementing all of CSS. So in a sense, that might seem like it's being somewhat restrictive. But I think if you think about our own work, managing CSS at scale is all about picking a reasonable subset of the language. You think about BEM, you are deciding to not do a whole lot of things that CSS can do. But you do this to make your app more maintainable, to unlock further abilities in your team, and to make your product more resilient over time. So that means that if you're working in React Native, you're not dealing with table layouts, you're not dealing with floats, you're dealing with Flexbox. And again, because we're working outside of the browser environment, we don't have the cascade, we have scope styles. But in some ways, this makes our app more maintainable and more portable. What this unlocks now is the ability for us to finally have cross-platform components with embedded styles, styles that are tightly coupled to the component in a way that makes them available to different platforms. A really good example of what this allows us to do is a project called React Native Web from Nicholas Gallagher at Twitter. And what React Native Web is basically allows us to have a drop-in replacement where you can alias React Native with React Native Web, and everything you've written for your React Native app can actually run in a browser. And this is what they're experimenting with at Twitter today. A similar project along the same lines is React Primitives by Leland Richardson. He works at Airbnb. And recently we've seen, funnily enough, React XP from Microsoft, which is a cross-platform component abstraction, which again includes its own style sheet system. But can we take our components even further? Not all of us are building native apps. Is there much value beyond that? We've seen a really interesting answer recently. I'm sure a few of you have seen this. React Sketchup by John Gold from Airbnb as well. And this is, to me, is really key, not just to the future of components, but to the future of design and how designers and developers interact. Because what React Sketchup lets you do is write React code with styles co-located with your components, but render not into a native app, not into a browser, but into Sketch. I'm sure most of you are probably not aware, as I wasn't, that Sketch actually has a JavaScript API, or actually a CocoaScript API. And that's what allows them to run this code in an environment that's typically targeting designers. We can bridge that gap in a really interesting way. And if, like me, you work day in, day out on design systems in the browser, this unlocks a really interesting potential of how we interact with our designers. And we can do really interesting things like this. Here's a video that John posted, which is showing responsive design style rendering into Sketch, all driven by code. And this is only possible because we've been able to write our markup and our styles in a way that's portable outside of a browser. What we're looking at here is finally cross-platform, cross-disciplinary design systems. We're having cross-platform code as the source of truth in our design systems. So instead of Sketch being the source of truth, or Photoshop, or PDFs, code is now the source of truth, but we can move that code back into an environment where the designers can also make use of it. So this has been a whirlwind tour of why people want to do CSS and JS, or at least why you want to be interested in it, at the very least. And just to recap all of this, it's all about scoping our styles to the component so that we can scale up to large systems and make them maintainable in a way that doesn't require so much careful hand-holding. It's about optimizing our apps in ways that we couldn't before. And then it's about taking our work and sharing it through package managers, again, in ways that we couldn't do before. It's about composing large applications out of that shared code and being able to build a community that we haven't been able to build before. And it's about unifying on a portable platform that can target multiple environments. It's about moving us towards a unified styling language, and it's doing it in a way that I never would have expected. And it's taken me a while to admit that this might very well be the future of how we do styling for the web and beyond. And this is what I'm bringing into my work day in and day out, because I work on a component system, and it's all about components. It's all about abstracting the styles behind a clean component interface, and I think this is the basis of how we're going to build better and better systems into the future. Critically, I want to do this without breaking progressive enhancement. I've come from a deep web background, and I really love what the web platform provides, and I think we can have the best of both worlds here. So when we think about learning CSS and we think about everything that we've just seen, all of this stuff, nothing prevents you from the fact that you still have to learn CSS. You still have to learn CSS. And that's where we all come in. The CSS and JS community is not done yet. There's still a whole lot of innovation happening, and that's where we need to get involved. Because there's a bunch of problems that are still being worked on. There's a lot of room for improvement, and the one library to rule them all has not been written yet. So we're looking at improving performance. We're looking at extracting static CSS where possible, hopefully as much as possible. We've seen people experiment with targeting CSS variables rather than targeting the web of several years ago. And finally, the most important thing, and I think this is where the people in this room can help the most of all, is making developers happy. Because what we're seeing here is potentially the future of CSS tooling, and we want to make sure that we get it right. And I really hope that from this, you take the message that this isn't as ridiculous as it sounds. There's actually some very sound thinking behind it, and your input is going to be really valuable. And hopefully, maybe you've come around to the fact that there's something to this and something worth checking out. So that's it for me. Thank you so much for listening.